Hi, this is Mrs. Rodriguez, your algebra teacher. This is a video review for the Chapter 7 quiz that's coming up. Okay, these questions are from my practice quiz that's in your textbook. Okay, remember I will go over the problems that are very similar to the ones that are going to be on your quiz, and then I may go over a couple of extra ones that are not in the quiz, but I'm sorry, that weren't in the practice quiz, but will be on your actual quiz. And I want to make sure you know how to do those types of problems. Okay, so what I recommend that you do while you're watching this video is have out a sheet of paper and something to write with. When you see a problem go up on the board, please try to solve the problem on your own first, and then play the video. If you get the problem correct, great, move on to the next problem. If you didn't get it right, see if you can identify your mistake as you're watching the video there. And then if you can't, make sure you stop by in my office hours or come by or call or email me so we can get that question cleared up before you take the quiz, okay? All right, so let's go ahead and get started. Okay, so like I said, this is a review for the Chapter 7 quiz that's coming up, and this is a practice quiz that can be found on page 421 of the textbook, okay? All right, so first section in Chapter 7 talks about basically the whole first 4 sections talk about exponents, right, or powers. So when you are multiplying a power with the same base, you add the exponents and keep the base the same, okay? If you are taking a power and raising it to a power, okay, like you are here, then you keep the base the same, and then you multiply the exponents, okay, together, all right? Because b to the 3rd power, that means raised to the 5th power means b cubed times b cubed times b cubed times b cubed times b cubed. So if we go back to the product of powers rule states that you add the exponents. Well, 3 plus 3 plus 3 plus 3 plus 3 is 15, okay? But a shortcut to adding all those together is just to multiply, right? Shortcut to adding repeated addition is to multiply. So that instead you would just multiply 3 times 5 instead of adding 3 5 times, okay? All right, so let's look power of a product, okay? To find the power of a product, find the power of each factor and multiply. Okay, so yeah, so same thing if you have multiple terms within the parentheses. So each one of these, it's kind of like the distributive property, each one of these you would have to raise it to the 5th power. So -2 to the 5th power, that means -2 times -2 times -2 times -2 times -2, which ends up being -32. And then you have to take x and raise it to the 5th power, so that's x to the 5th power, and then y to the 3rd raised to the 5th. You multiply the exponents, so that's y to the 15th power, okay? And then to simplify a monomial expression, okay, you have each variable base appears exactly once, okay? There are no powers of powers, okay? And all fractions are in simplest terms. So all 3 of these things have to happen in order for a monomial expression to be simplified, okay? All right, so let's look at a problem. It says to simplify each expression. So we've got x to the 3rd times 4 times x to the 5th, okay? So I need to multiply. I have this, we could rewrite this as 4 times x to the 5th times x to the 3rd. So I'm multiplying not 4 by nothing, it just stays the same, or a 1, 4 times 1 is still 4. And then x to the 5th times x to the 3rd, I keep the base the same. And then I'm going to add my exponents, so that would be 4x to the 8th power, okay? and that would be my final answer. So one thing, you want to make sure that you're showing all of your work. So if all you have is this on your paper, and let's say by accident you added 5 and 3, and by accident you got 7. Let's say you made an arithmetic error, and that's all I see on your paper, you're going to lose all the points for that problem. So, but if you show me this step, I can see, oh, they know that they're supposed to add the exponent. They just made a little arithmetic error, and I would just take off 1 point for that. Okay, so strongly recommend for you guys to show your work, however simple or easy you might think that it is. Okay, better to show all of your work. Okay. All right. So next problem, we're going to multiply each one of these terms. So 6 times -3, that's going to give me -18. And then, let me just change colors here. Then I've got to multiply a times a squared. So remember, this is a to the first power. So a to the first times a to the second. That would be a times 1 plus 2. And then I'm going to change my color here again. I've got b cubed times b cubed, so I keep my base the same, and I'm adding the exponents, and then I've got c to the 4th times c to the 1st, so that would be c to the 4th power plus 1, okay? And then for my final answer, I would have -18. A to the power of 1 plus 2 is a cubed. B to the power of 3 plus 3 is b to the power of 6. And then c to the power of 4 plus 1 would be 5. Okay? So I cannot, all of these variables are different. I cannot combine any of these. And I can't do anything with my constant in the front either. Okay? So we're all set. Okay. Then it's the next section talks about the quotient of powers. So if we were multiplying powers with the same base, we were adding the exponents. Now if we're dividing powers with the same base, our base stays the same, and this time we are subtracting our exponents, okay? And then a power of a quotient. To find the power of a quotient, find the power of the numerator and the power of the denominator, okay? So if you have a fraction that is being raised to a power, that means you raise the numerator to that power and the denominator if it's in the parentheses. Okay, if it just said 3 to the 4th over 5, that you would just raise 3 to the 4th power, not the 5. Okay, but in this case, all of this is in the parentheses, so the numerator, you raise it to the 4th, and the denominator, you raise it to the 4th power as well. Okay. Oops. Okay, and then it says here any non-zero number raised to the 0 power is equal to 1. So anything raised to the power of 0 is equal to 1. It could be -1 raised to the power of 0 is still equal to 1. Okay, anything raised to the power of 0 is equal to 1. And then for negative exponents, if you have a negative exponent, this is actually a fraction because this is a small number, okay? So you end up this ends up becoming your denominator without the negative exponent, okay? So it's 1 over 2 to the 4th, which is equal to 1/16, okay? All right, so let's look at a couple of problems here. So the first one, we're raising all of this to the 3rd power. Okay, so every term in the numerator and the term in the denominator, we're raising that to the 3rd power. Okay, so 2 to the 3rd power, a to the 4th times 3, because we're raising a power to the power, and then b cubed times 3, and then c to the 6th times 3 as well. Okay, so then, oh, what happened? Okay, Sorry about that, that was weird. Okay, just trying to change my color here. All right, so then I have 2 raised to the 3rd power. Remember that means 2 times 2 is 4, times 2 is 8, okay? And then a to the 4th power times 3 would be a to the 12th power, and then b to the power of 3 times 3 would be 9. C to the power of 6 times 3, that's 18. Okay, we cannot simplify anymore, so that is our final answer. Okay. Okay, next problem. Here, we're actually going to simplify here. We've got powers, we're dividing powers with the same base, so we're going to subtract. So we're going to take the base m and subtract 7 minus 3. You've got n to the power of 4 minus 3, and then p to the power of 1 minus p to the power of 1. Okay? All right, so then m to the power of 7 minus 3, that would be m to the power of 4. And then n to the power of 4 minus 3, that's 1. So we can leave it as n. And then p to the power of 1 minus 1, well, that's 0. Okay, and anything to the power of 0 is just 1, so that when you multiply, it just ends up being m to the 4th times n, and that is our final answer there. Okay. All right, next section talks about solving exponential equations. So in an exponential equation, variables occur as exponents. That means you're going to have variables in as part of the exponent. It's not just going to be like a 2 or a 7 or something like that. So the power property of equality and the other properties of exponents can be used to solve exponential equations. So basically what that is saying is, if you can get your bases the same, then your exponents are going to be equal to each other, and then you can solve for the variable within your exponents. Okay? So here, since both of these had a base of 5, we could set x equal to 3. Okay? All right, so let's take a look at one of these. So this says 4 to the power of x is equal to 4,096. Okay? Well, I need to figure out, I see that I have 4 to the power of x. I want to rewrite this with a base of 4. So in other words, 4 to the power of what to what exponent is 4,096. Okay, so this will require some calculator trial and error here. And I would just take a calculator, do 4 times 4, and then multiply by 4 again, 4 again, multiply by 4 again, and keep multiplying until you get 4,096, keeping track of how many times you multiply. Okay, if you do that, after multiplying 4 6 times, you will end up getting 4,096. So again, you put 4 in calculator, multiply that times 4, multiply that times 4, multiply that answer times 4, and then stop at 4,096. Okay? So if you put 4 to the 6th power in your calculator, you end up getting 4,096. So now our bases are the same, so we could set our exponents equal to each other. So my exponent here is x, my exponent here is 6, so x is equal to 6, okay? All right. So next problem here, I have 5 to the power of 2x plus 1 is equal to 125. Okay, so nothing I can do to this, but I want to rewrite 125 to have a base of 5. Okay, well, I know 5 to the first is equal to 5. 5 to the second is equal to 25, because 5 times 5 is 25. And then 5 to the third, 25 times 5 is 125. So I know 5 to the third power is the same as 125. Okay, so that means I can set my exponents equal to each other. 2x plus 1 is equal to 3. Okay, so now I can go ahead and solve for x. Okay, this is just a two-step equation. You guys have been doing this pretty much all year long. Divide both sides by 2 here, so x is equal to 1. Okay, and that's the final answer. All right, next section talks about scientific notation, okay? So scientific notation, remember, is a way to write really big numbers or really small numbers, okay? So you move the decimal point until it is to the right of the first non-zero digit, and the result is a real number, okay? Note the number of places in and the direction that you moved the decimal point, okay? If the decimal point is moved to the left, then you would write the number as a times 10 to the power of positive n. If the decimal, you moved it to the right, then you write the number as a times 10 to the power of negative n being the number of times you moved your decimal point. And then you remove any unnecessary zeros, okay? Also, note that n has to be between greater than 0 or less than 0, okay? If n is greater than 0, move the decimal point and places to the right. And then if n is less than 0, you move the decimal point, negative n places to the left. That's if you're going from scientific notation back to standard form. And then you insert zeros and a decimal point and commas and needed for place value. Okay, so let's look at a couple of these. So here it says to express each number in scientific notation, okay? So what we are going to do, first of all, you're going to make note. This is a very small number, okay? So our exponent should be a negative, so keep that in mind. So we want to move this decimal point as far as we need to until we get a number greater than 1 but less than 10, okay? So we move over 1, 2, 3, 4, 5, 6, 7 times, okay? So we moved to the right 7 times, all right? So when we move this, we end up with 5.4, okay? Times 10, and since we moved to the right, that is going to be a negative exponent, okay? So it's 5.4 times 10 to the power of negative 7, okay? So really small numbers have a negative exponent, okay? All right, next problem. This is a really large number, so we're gonna have a positive exponent here. Now you might be thinking, well, where's the decimal? Okay, well, the decimal, when we have a whole number, the decimal is here at the end, we just don't write it, okay? It's understood that it's there, okay? So we're gonna move our decimal point, and we want it to end up here in between this 4 and the 1, okay? Because remember, we want a number greater than 1, but less than 10, okay? So we move it over 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, so we moved it to the left 8 times. So we've got 4 and 1800ths times 10 to the power of positive 8. Okay, because this is a very large number and we moved our decimal point to the left. Okay. All right. And then this one says, evaluate each product or quotient, express the results in scientific notation. Okay, so what you should have read in the textbook is that you can apply the commutative property of multiplication here. We can rearrange this because you're multiplying everything out. So we can rewrite this as 2 and 1300ths times 3 multiplied by 10 to the 2nd power times 10 to the 5th power, okay? So then when you multiply 2 and 1300ths times 3, we end up with 6 and 3900ths. And then here we're multiplying powers with the same base. So 10 to the 2nd power times 10 to the 5th, we keep the base and add the exponents. So written as scientific notation, it's 6 and 3900ths times 10 to the power of 7, okay? And that's all for that one. So for number 37, very similar problem with just one additional step here, okay? So we're going to rewrite this as 7 1/2 times 2.5 times 10 to the 6 times 10 to the power of -2. Now here, when you multiply 7.5 times 2.5, that's 18 and 75 hundredths, okay? And then 10 to the 6 times 10 to the power of -2, you would add these exponents. 6 plus -2 is +4. So, but here, we cannot have 18 and 75 hundredths if we're going to write this in scientific notation, okay? Because this term needs to be greater than 1 but less than 10. Okay, so we've actually got to move this over one place value, right? So this ends up becoming 1 and 875 thousandths times 10 to the first, because we moved our decimal point over once, times 10 to the power of 4. Okay. So again, we've got 1 and 875 thousandths, and then 10 to the first times 10 to the fourth. We add those exponents together. Okay, so this one had an additional step because this term, remember the first term in scientific notation, needs to be greater than 1 but less than 10. Okay, so that is our final answer. And then problem number 39 says to evaluate each product or quotient, express the results in scientific notation. Now here we are dividing, okay? But same, we can still apply the commutative property here. We can break this up into 6 and 6/10 divided by 2 times 10 to the 5th over 10 to the power of -3. Okay, so we end up with 6 and 6/10 divided by 2 is 3 and 3/10, and then times 10 to the power of, I'm going to subtract 5 minus -3. So that becomes 5 plus +3, which is 8. So 10 to the power of 8. So it's 3 and 3/10 times 10 to the power of 8. Okay. All right, so that concludes the review for the Chapter 7 quiz. Remember, if you have any questions about any of these problems, please make sure you either stop by my office hours or call or email me so we can get your questions answered before you take the quiz, okay? All right, remember, I'm here to help you be successful in this course. All right, you have a great day, and hopefully we'll see you soon. Bye-bye.